Okay, so let's go back to our notes. We're starting with number 9, I think. And we have our little reference sheets with us. Because I think having the reference sheet with you is going to make this problem a whole lot easier. Look at your reference sheet, just what we circled, and tell me if you see anything kind of special for this problem. Anybody see anything?
Yeah, it's if the tangent thing is equal to secant squared.
1 plus tangent squared is secant squared. Look at your paper, that's what it says, right? So, I'm going to change my 1 plus tangent squared into secant squared. Now, you don't have to do that, but doing that is going to make this problem a lot easier, because tell me what you know about secant. It's the reciprocal of the cosine. So now I have my cosine, my regular old cosine here, but it's being multiplied by 1 over cosine squared. Secant squared, reciprocal of cosine, 1 over cosine squared. You might write this down right here. All right? So tell me now, what happens? Yep, we can cancel out not all of it, because I only have 1 here, and it will cancel with this one here. So what am I going to be left with? 1 over cosine, which I know is
secant.
Secant. Now it's fine if you leave it as 1 over cosine. That's absolutely fine to leave it that way as 1 over cosine, but it is secant. Okay? All right, number 10. Who remembers what I did with problem? We did a couple of these on whenever we did this. Who remembers what I did when I had problems that looked like this? Anybody remember? I wrote it sideways, as this one would be tangent squared divided by secant squared. And I did that because I'm going to change both of these into something else. What am I going to change tangent squared into? What is tangent? Sine over cosine. So this is going to be sine squared over cosine squared. Remember, the sheet just says tangent is sine over cosine, but if it's squared, that just means everything's squared. Divided by, what's secant squared? This is not on your sheet, this you have memorized. What is secant squared? 1 over cosine squared. Now what do I do now with this big division problem?
Keep change flip.
I keep change flip, so sine squared over cosine squared times cosine squared over 1.
Sine squared.
That's going to cancel, and I'm just going to be left with sine squared. They're getting a little easier, aren't they? This is still craziness for sure, but they're getting a little easier. Okay. All right, I've kind of got you warmed up. Tell me what you might want to do with this problem. Do you have any thoughts at all?
Can we cancel out the signs?
We can't cancel them out. What can we do with them?
Combine them.
We can factor them out. it's like a GCF, we can take out the sine squared. They don't cancel because, first of all, they're not being multiplied. You have to have something like this going on to cancel them, right? These are not like terms, so you can't subtract and cancel because they're not, this one has a secant, this one doesn't. So can't do that, but you can factor out a sine squared because both terms, as you notice, have a sine squared. Now what will be left in the parentheses if I factor out the sine squared? Secant squared minus 1. Remember, if you take out the whole thing, the whole term, you have to put a 1 in there. Now this is a little tricky. I want you to look at your sheet. And on your sheet somewhere, do you see and I'm talking about the circled parts, the parts we look at. Do you see a secant squared on that?
Tangent squared plus 1.
So secant squared is 1 plus tangent squared. So what that means is I can take this secant squared, right here, this guy, and I can write him as 1 plus tangent squared. So the parts with the little brace underneath, those are equal. Your sheet, which is kind of like your Bible right now, says secant squared is the same as 1 plus tangent squared. When you see these ones are going to cancel, do you see that? I have a 1 minus a 1. Do you see that, everybody? So I have sine squared times tangent squared. Any idea about what I might do next? We've done it already today. Any ideas about what I might do?
Changes the sign of the cosine.
Exactly. Tangent squared is sine squared over cosine squared. Oh, shoot. Usually when we make that change, things cancel. Not this time, right? Nothing's gonna cancel, these are both on top. So I'm gonna multiply. What do I get when I multiply these together? What's in my numerator? I'm multiplying sine squared times sine squared. It's like, what do you get when you take a squared times a squared? A to the 4th. So this is going to be sine to the 4th over cosine squared. That does not simplify. That doesn't go any farther. We are done. We are done. Always get it changed into sines and cosines. Take it as far as you can, and then you're done. That's it. Okay, so this was tricky. We factored out a sine squared. Then we got this secant squared, which we know is on our sheet. So we replaced it with 1 plus tangent squared. The 1's canceled. So that left us with just sine squared times tangent squared. So we changed tangent into sine over cosine, but we couldn't do that when we multiplied. So we were just left with that. Alright. Anybody see anything about number 12? I bet you can if you're paying attention. If you're looking at it closely. First of all, nothing cancels. Please don't get wild and wacky. You can't cancel parts. The only way you can cancel is if the whole thing cancels. These are not the same, so I can't cancel. No canceling pieces.
Simplify the 4 and 2.
They simplify what?
4 and 2.
No, because you can't reduce that. You can't cancel a 2 out of here because of the minuses. Don't be trying to reduce, don't be trying to cancel, don't be trying to do any of that unless you have factored first? Does the numerator factor? Does the numerator factor?
Yes.
Well, yes, you can tell by the way I'm asking the question. How does it factor? Huh? They're not cubes, they are the difference of squares. How do we factor the difference of squares? Plus 2 and cosine x minus 2. Guys, we gotta remember that factoring squares is a big deal. You gotta remember that. A squared plus b squared is a plus b, a minus b. You just gotta remember that. So this one is cosine plus 2, cosine minus 2. Now what can I do? Now I can cancel because I'm canceling out the whole thing, the whole factor. I can't cancel out just the 2, I can't cancel out just the cosine, I can cancel the whole shebang. But I can't do that until I factor. Okay? So my answer is just cosine plus 2. That's probably gonna be a test question, that's my guess. All right, let's look at number 13. Tell me what you think.
Change secant squared to tangent.
Secant squared is 1 plus tangent squared. It is. What am I going to do then? If I do that, what would I do then? I could FOIL. Okay, I'll go with it. I don't think this is a very good idea. But we're gonna try it because you don't know. You haven't practiced enough, so you don't know. So you gotta jump in and do this. Alright, so you change your this is absolutely right. Secant squared is 1 plus tangent squared. That is absolutely correct. So now I'm going to FOIL first, outside, inside, last.
Ms. Ford? Yeah, that's my question.
Okay, now what? We're here, now where do we go? I think I like the way you're thinking about using your Pythagorean identities. Those ones you circled are called the Pythagorean identities. I'm glad you're thinking about those, but instead of changing this one, I'm gonna change this one. Because I know that sine squared plus cosine squared is 1, right? I know that, that's a biggie. We should probably have that one memorized close already. If I subtract this over to the other side, what does that equation now say? What does it say now? Cosine squared equals 1 minus sine squared? That's the same equation, you guys. It's just things are rearranged a little bit. what does it say now? It says 1 minus sine squared is the same as cosine squared. So let's not do this. Let's look at this and think of it as cosine squared. So now the problem says secant squared times cosine squared. Now, if you're really thinking, you know that's going to be 1. Because what is the relationship between secant and cosine? Reciprocals. So what happens when you multiply reciprocals, like 2/3 and 3/2? What happens whenever you multiply reciprocals? They cancel out and make 1. Now, if you didn't quite get that, remember, this is 1 over cosine squared. This is cosine squared over 1. See how they're going to cancel and make 1? Would we eventually, if we kept going with purple here, would we eventually get there? I think we would, but I think we'd still have to do this substitution right here. I think we'd have to do that to make it all come out. So, you were thinking along the right lines. 1 minus sine squared is cosine squared. Always, always, always. If you want to write 1 minus sine squared as cosine squared, do it. That's what it is. Okay, what number was that? 13? Okay, so we're ready for 14 now. And in a minute, you're going to get to do some of these on your own. Hold on to your hats. All right, so cosecant. Remember, if you don't like the thetas, you can change them to x's. Okay, I need an idea.
Switch tan into sine over cosine.
Okay, and while I'm at it, why don't I switch cosecant into what? What's
1 over
cosecant?
sine.
So I'm going to think of this as 1 over sine, and then tangent is sine over cosine. And then I might as well change that into 1 over cosine. I love the way she's working this. She's thinking about changing everything into sines and cosines. What's the benefit of that? If they're all sines and cosines, might I cancel? Yeah, I can't cancel when they're cosecants and tangents and secants, but if I make them all the same, I might be able to cancel. These are 2 separate parts of the problem. They're not in parentheses. They don't need to be in parentheses, but please understand they are separate. So look at here. What happens here? The signs cancel, and I am left with 1 over cosine. Plus another 1 over cosine. So who said it? What is that? 1 over cosine, and 1 over cosine gives me a total of
Secant.
2 over cosine. But this 1 over cosine thing, what are those the same as? 1 over cosine is the same as
No.
secant. So this is a secant and another secant. So you can either write it this way, or you can write it this way. This is secant, and this is secant, and I'm adding them together. So secant plus secant. All right. Okay. I see a couple of them things right off the bat on this problem. If you were listening a minute ago, I've erased it already. But what happened when we multiplied a cosecant times, a cosine times a secant? What happened when we multiplied them? They canceled into one because they were reciprocals, right? So I want you to look at this first term right here. What do you notice about this guy right here? Isn't that one? Because aren't these reciprocals of each other? And when you multiply reciprocals, you get 1. So 1 minus sine squared. This here, all this right here, just makes 1. And that is cosine squared. Awesome, Olivia. She was listening when we said up here that cosine squared is 1 minus sine squared, and sine squared is 1 minus cosine squared. Always, always, because of that fundamental identity that says sine squared plus cosine squared is 1. There are other ways, of course, you can do this problem, but this is kind of an obvious way. We've got reciprocals right here being multiplied, and then as soon as we did that, then we were left with our identity. Okay, how about 16? I bet you can start 16. Okay, first of all, is what's in the parentheses 1?
No.
No, because they're not square. But I am squaring this parentheses. So doesn't that mean that I am timesing the parentheses times itself? Isn't that what that means? So what are you gonna do with that? Foil it, yep. Start foiling. First times first. Outsides, insides. And last.
Don't they equal just 1? This sine plus cosine equal 1?
Not
Oh.
sine plus cosine, they have to be squared. When you foiled, though, did you get a sine squared on one end and a cosine squared on the other end? So these, after I foil, and they're squares, these make a 1. And what do you notice about these two? Now remember, this is a multiplication, sine times cosine. This is a multiplication, sine times cosine. Aren't these like terms? So you got one of them here and one of them here. So when I add them together, I'll have 2 of them. And we are finished. That's all you can do with that guy. You got the 1?
Well, because I originally just added the 2, so it would make sine squared x. I just did it a really stupid way, and I realized I did it wrong right before you started.
Okay. Well, I want to remind you all this is a foil guy. We don't just square the pieces. You have to foil it. Okay. All right, one more in our notes. Here we go.
It's just a bunch of letters at this point.
Yep, just a bunch of letters.
Before it's just a letter, just like doing this math.
FOIL? FOIL? I mean, it's a mess, but at least it's all cotangents and cosecants, so I can multiply these and get cotangent squared. And then these are gonna give me plus cotangent cosecant. Now, guys, please don't let yourselves be confused because it's all letters. You FOIL just like you always FOIL. So take first times first, outside times outside, inside times inside, and last times last. And remember, if it bothers you to write your cotangent squared this way, you can always write it this way if that makes more sense to you. It's the same thing. Okay, anything happen? Aren't these the same?
Yeah.
You guys, multiplication's commutative. Cotangent, cosecant is the same as cosecant, cotangent when you're multiplying them. And that one's positive and that one's negative, so they're gone. So I have cotangent squared minus cosecant squared. Well, let's look on our sheet. Do we see a cotangent squared or a cosecant squared anywhere?
Cosecant squared equals 1 plus cotangent squared.
So this guy right here is 1 plus cotangent squared. So what if we did this? What if we said minus 1 plus cotangent squared? These parentheses are necessary since I'm subtracting, because what's going to happen with that minus sign? It's going to go to both parts. So now I've got cotangent squared minus 1 minus cotangent squared. What's this end up equaling?
Negative 1.
Alright, that homework is gonna be due on Wednesday. But I wanna give you a head start on it, I wanna give you a little help. I'm not gonna do them all. But here's what I will do. Let's get our homework out. And I will do 3 of them. And I will let you pick the 3. That's half. I'm gonna do half with you. You're gonna do the other half on your own. Okay? So everybody's got their homework out?
Yeah, that's what I was also gonna say.
Huh?
3, 5, and 6.
3, 5, and 6. Okay. Alright, so I am doing 3, 5, and 6, because that's what the front and the back of the room both want that apparently. So here we go with number 3. Alright, first thing, just as I'm writing it down, these are all multiplied, right? So when things are all multiplied, I can start canceling. And in order to make that happen, maybe I should do what we did in an earlier problem. Maybe I should change my tangent into sine over cosine. Just keep the negative, it's just part of the problem. It doesn't change anything, just stays negative. Now, that's this one. Now the next term is a plain cosine. Don't change him. We're changing all of the weird functions into sines and cosines. So cosine just stays cosine. And since that's a fraction, I went ahead and made that over 1 to keep everything kind of lined up. All right, what about cosecant? 1 over sine. Now the next one's sine squared. We're not changing him. We're just keeping him sine squared, but I will put him over 1. And what about cotangent? Now, stop and think about what you just said. First of all, you are right. Cotangent's 1 over tangent. But does that fit what I'm doing here? Cosine over sine. Change it all into sines and cosines. We almost never change a cotangent into 1 over tangent. We almost always change it into cosine over sine. Everybody still with me? Now the whole thing is multiplied. So anything on top cancels with anything on the bottom. So do these cosines cancel right here? Yep. That sign and that sign cancel?
Does the other one cancel with the one on the bottom?
Yes. So I got 2 on the top and 1 on the bottom. So that one will cancel with that part and just leave me 1 sign. Am I done? So I have a negative, don't forget the negative. And it looks like I just have sine times cosine. Is that what you came out with? And that's it. That's your answer. Five looks very similar. Would you agree? It looks like kind of the same thing. Right, so here we go. Just bring the 2 along for a ride. You can make it 2 over 1 if you want, since all these are going to be fractions. You can make that 2 over 1. Now, how about tangent? Sine over cosine. How about cosecant? Cosecant is 1 over sine. Now, this guy is a cosine squared. Just leave him cosine squared over 1. Remember, we're changing everything into sines and cosines. All right, cotangent? Cosine over sine. And then we have our sine over 1. Okay, so it looks like that sign will cancel. And that one will cancel. So the sines are gone. What about the cosines?
The one is
He'll cancel with him. But it looks like my answer is going to be 2 cosine squared. Looks like that's all that's left. Everybody okay with that? All right, then the last one I'm doing for you is number 6. And we're not gonna, it's not the same kind of problem. Can you tell by looking at it? It's not like these last 2 we did. It's not just a bunch of things multiplied. It's a big, ugly fraction. However, as I am writing it down, my heart is going pitter-patter because what do I see on the top?
You can make that into a 1.
You can make that into a 1. Absolutely. Sine squared plus cosine squared is 1. So I have 1 plus tangent squared over secant.
Secant squared over secant.
Exactly. Guys, I'm older than you and I've done a whole lot more than you have. But look on your sheet. Don't you have one of your circled things that says 1 plus tangent squared?
Yes.
equals, so the numerator is secant squared over secant. Can I cancel?
Factor.
Aren't these the same? So I'll just cancel one of them out and leave me with just plain secant. This is like x squared over x. Okay? Now, the other ones, Allie, I want you to put that away now. We're putting away our homework. We're gonna work on something else real quick. So I want you to put away the homework. We're not looking at the homework. You only have 3 problems to do. You can like actually do them at home. Or during resource or something. All right, I want you to get the packet that I just gave you today.
Oh, I definitely did.
All right, I want you to keep your reference sheet handy. We're gonna do the front side real quick, and then we're gonna do the back of the front page, which is more practice of what we've been doing. We're not gonna have a memorization quiz. I don't make him memorize all this stuff anymore. Used to, back when I was a real teacher, they had to memorize it. You guys don't, I give you this reference sheet, but let's fill them in using our reference sheet. Cosine squared plus what equals 1?
Sine squared.
Sine squared. So even though we're saying sine squared, make sure you're writing sine squared theta. Gotta have a theta or an x attached. Now this you do have memorized. Cosecant is 1 over sine theta. That's right, 1 over sine theta. Perfect. Now this one's a little tricky. One of them's easy, one of them's a little harder. Can you think of 2 ways to express tangent? Sine over cosine. That is the most obvious. Sine over cosine, it's on your sheet. But what else do we know about tangent?
Cotangent over 1.
It's 1 over cotangent. 1 over cotangent. It's the reciprocal of cotangent. We don't usually do that because in fact, we may never do that, you and I together in this class, but it is true. Tangent is 1 over cotangent. And then number 4, 1 plus what? Tangent, tan squared, right off your sheet, tan squared. All right, let's do the bottom. In fact, you do the bottom, and then you'll check. So do the bottom part, do the same thing, fill in the blanks. Ahead and put my answers up on the board. Do they match yours? Does anybody not match something and wonder about something? Yeah, this is kind of uncommon for us. Normally cotangent, we're going to say cosine over sine, but it is also 1 over tangent, reciprocal of the tangent. Everybody good? Okay. On the back side where it says extra practice 5.1, look them over there. Gosh, there's 23 of them. Look them over. Just Anybody see one that looks maybe a little more challenging? Something maybe we need to do out loud. 7. Now, actually, we've talked about this today. Does anyone remember anything about 1 minus cosine squared? It's sine squared. 1 minus cosine squared is sine squared. Now, I'm not going to write that on your test reference sheet, but if you want to write that on your reference sheet and get used to seeing it and practicing it, because we use it a lot. The numerator then, Allie, is just sine squared. So now we have sine squared over sine, which is sine. Yep. Anybody see another one on there that bothers you?
21.
21. 21 is sort of similar to the ones we were doing earlier. It's a bunch of stuff multiplied. So do you remember our strategy? When we had a bunch of stuff just in a row being multiplied, what did we end up doing? What did we do with all that? Making fractions in terms of sines and cosines. So what about tangent? Sine over cosine. Okay, what about secant? 1 over cosine. And what about cosecant? 1 over sine. So Sharon's exactly right. When we have all these things multiplied together, she said we're going to turn them all into fractions. And the fractions we turn them into are sine and cosine fractions. So what happens? A sine cancels. I think that's it, isn't it? So what are we left with?
Cosine squared.
1 over cosine squared, which is fine, or we could write that as
Secant squared.
secant squared, because 1 over cosine is secant. All right, another one. Come on. Which one? 5. Now, this one is a little tricky. You have to kind of be in tune with your circled identities on your sheet. Is there a relationship, in other words, an equation, that ties tangents and secants together? On your sheet, is there an equation that links tangents and secants?
1 plus tangent.
1 plus tangent squared is secant squared. Everybody agree with that? So what if I took this equation and subtracted 1? Then it would say tangent squared equals secant squared minus 1. So I could take this and plug it in here. Is that okay? So now I have secant squared minus 1 over secant minus 1. Caution, we had this earlier. Can I cancel anything here? No. You can't cancel it until you factor it. Does that numerator factor? Yes. It's the difference of squares. How does the top factor? How does that factor? Secant minus 1, secant plus 1. The difference of squares. This is the last time I'm going to talk about it, guys. You need to know this. The difference of squares. Anytime you have two squares minus each other, and this is secant squared, that's 1 squared, you can pull them apart. Secant minus 1, secant plus 1. Now what can I do?
Cancel.
Now I can cancel. So my answer is just secant plus 1. You cannot cancel at this point. There's no canceling. You have to factor first, and then you can cancel. Looking for another one kind of like that. What about number 10? Have I got a 10 yet? I don't think so. What about number 10? Nobody notices anything about number 10?
Cosine squared.
Cosine squared's on the top, isn't it? So now I have cosine squared over cosine, which is just
Cosine.
cosine. Perfect, perfect, perfect. 17. I'm surprised nobody asked about that one. Or maybe you don't need to ask because you recognize the denominator. What's 1 minus cosine squared? Sine squared. So all we have is sine cubed over sine squared, which is going to cancel and make sine. Yeah, that was easy, but looked freakishly hard. How about number 20?
Plus tangent squared minus tangent squared.
Okay, so Jacob said, on my paper circled or starred, I have an identity that says 1 plus tangent squared is secant squared. So he says, what if I take this and plug it in here? Is that legal? All right. So then we have 1 plus tangent squared minus tangent squared over, whoa. What about the bottom?
1.
Did I copy this right? I want to make sure, right? For which problem am I doing?
20.
Oh, it's supposed to be cosine squared plus sine squared. How did I get that? Do I have this copied right? Now I do. Okay. So what about the bottom?
1.
The bottom's just 1. But what about the top? These cancel. Isn't the top just 1? So we have 1 over 1, which is 1. Aren't they getting easier? I told you they'd get easier. I told you they'd get easier. All right, let's do another one of the long ones. Looks like 18 might be the longest. So let's do 18. And then I'll be done, okay? 18, here we go. Okay, Xavier, look at this big, long problem. Notice, though, that it's all multiply, right? There's no adding, there's nothing, like that, it's just all multiply. So what have I done in my other all multiply problems? What's been my strategy? Okay, Sharon, tell him, what did you say last time I asked this question?
You make
Make them into fractions, okay? Now, sine does not go to a fraction, you'll make it sine over 1. Cosine is just cosine over 1. We don't change sines and cosines. But tangent, we do change. What's tangent?
Sine over cosine.
Sine over cosine. And what's cotangent? Cosine over sine. And what's secant? 1 over cosine. All right. Now, Xavier, are you with me? You see what we just did? Xavier? Okay. So we changed each, when we have a big problem that's all times, like this, we're going to change each thing into a fraction. If it's a sine or a cosine, just put it over 1. If it's anything else, change it into what it equals. Okay? Now, what happens then?
Sines and cosines.
Hopefully some things cancel. That will cancel, that will cancel, that will cancel. Does that whole thing just come down to sine? Now I want to show you something. For those of you that are getting good at this and starting to feel really comfortable with this, do you see these guys right here? What's going to happen when you multiply a tangent times a cotangent? Isn't that going to give you 1? Because they are reciprocals? So you could actually cancel those out. Look about this. What happens when you multiply a cosine times a secant?
1.
They cancel each other out. So for those of you that are getting good at this, you could just look at this problem and say the answer is going to be sine, because these reciprocals are going to cancel each other out. All right, well that homework's due on Monday, or Wednesday, due on Wednesday. Next class, we're going to practice for a quiz, and we'll have a little 2-problem quiz coming up, but not in the